Hello, friends. Jim here with Science Talk. Um, I wanted to share with you some thoughts about what we've been seeing a lot of in the headlines lately, and namely involves will the Gulf Stream shut down totally in 2 to 3 years? Okay, let's put these sensationalistic headlines aside. No need for that. And let's take a look at what the past has informed us and compare that to current situations. Now, when they talk about the Gulf Stream slowing down, what you're really talking about is AMOC, the Atlantic Meridional Overturned Circulation, slowing down. The Gulf Stream, of course, traverses up the western Atlantic Ocean basin, continues past Newfoundland, heading towards the Jin Sea, Greenland, Icelandic, Norwegian Sea, gives off its heat, becomes cold and salty, very dense, and sinks. Well, we have a lot of meltwater being added in there, which is diluting surface waters, making it less dense and less likely for the water to sink. So AMOC is slowing down. Team of researchers from Dalhousie University in Dartmouth, Nova Scotia, as well as some Norwegian research teams, have measured this slowdown. And of course, when AMOC sinks, it pulls the Gulf Stream along with it. So if AMOC is slowing, then the Gulf Stream is slowing as well. So that is happening. Will it shut down in 2 to 3 years? Short answer, no. In order for it to shut down in 2 to 3 years, the rate of slowdown of sinking has to dramatically increase. And indications are the level of slowdown that required to have it completely stop within 2 to 3 years is currently not happening. The work of Wally Broker indicated that for AMOC to shut down totally, it's about several decades. How long has this slowdown been quantified? About 2 decades. So maybe we got 10 to 20 years if things continue. Certainly not in 2 to 3 years. Now, what are the ramifications? In the past, when AMOC slows significantly or totally shuts down, there was at least hemispheric cooling. And depending on the extent of the slowdown / shutdown, even global cooling. If you look at the videos I made from 3.5 years ago when I first started my channel, I was saying that global warming can lead to a cooling down of the planet because of the very fact of shutting down the conveyor belt, which is colloquially called, which is a heat distribution mechanism for the planet. So now instead of bringing warmth from low latitudes to high latitudes, cold and cooler conditions from high latitudes to low latitudes, all the heat stays in the low latitude, all the coolness stays in the upper high latitudes, creating a greater differential. That's what the past has indicated to us. Fast forward to 2021, and the oceans now have absorbed 220 zettajoules of energy. And the sinking is not happening, so that heat, along with the CO2, is not being sequestered. It's staying in the upper layers, upper 500, maybe 700 meters. So, in my view, because of all this heat energy, which is being diffused through the atmosphere, I do not expect to see hemispheric or even global cooling. I do expect to see regional cooling, namely the UK, Scandinavia, Baltic states, northern Germany, France, that region. I expect to see regional cooling. I do not expect to see hemispheric cooling because of all that heat energy in the ocean. Now people say, But if the Gulf Stream slows down, won't that stop the warm water that's going into the Arctic Ocean? Okay, let's consider that. There are three major points of entry into the Arctic Ocean from where warm water is brought in. First, from the Pacific side through the Bering Strait. That's shallow, about 50 meters deep, and I've discussed so far some of the papers showing how much more heat is being transported in, the duration is staying longer, and so forth. So we do see heat being brought in, more of it, a higher flow rate, it's lasting, persisting longer in the Arctic Ocean. You have also water coming in through the Barents Sea opening. Now, this is part of the Atlantic North Drift, when the Gulf Stream turns into that. So, yes, it is not unreasonable to expect some reduction in warm water being introduced into the Arctic Ocean via the Barents Sea opening. What's the third one? The Fram Strait. Now, the Fram Strait is really the only deep connection from any of the other oceans into the Arctic Ocean. Surface waters, yes, you may see a cool down of the surface water there. You may see a reduction of warm water going into the Arctic Ocean. But the main supplier is the North Atlantic Intermediate Water. Now, before I get to that, let's consider the Gulf Stream. The Gulf Stream typically goes down to a depth of about 800 meters or so, depending, 700, 800, 1,000 meters, something on that range. When the deep water formation, the North Atlantic deep water, as that sinks, typically it finds its buoyancy forces at about 1,500 to 2,000 meters down. And basically, what is underneath that water is the Antarctic bottom water that actually infiltrates all the way from the Southern Ocean through the South and North Atlantic Oceans. So it finds a point where, okay, this is how dense we are, this is how far we can sink. So what about between 800 meters and 1,500 meters? And by the way, if you noticed my ocean heat content video, I talked about how we measured heat down to 2,000 meters. That's basically the bottom layer of the North Atlantic deep water as it's sequestering that heat. Okay, what's in between? 800 meters or so down to 1,500 meters or so. That's where the North Atlantic Intermediate Water is found. That flows right into the Arctic Ocean. Now the question is, what is the source of the NAIW? The Mediterranean. The Mediterranean Sea, first of all, it has some of the highest salinities of any of the oceans that are found. So it has a high salinity. And yes, it is very warm water. Now it comes to the old question, because a density of seawater is determined by temperature and salt content, salinity. And the old question always comes up, which is more dense? Cold, less saline waters, warm, more saline waters? And the answer is, it depends. But because this water has a high salinity value, somewhere in the order of 35.5 up to 37.2 or so practical salinity units, it is very warm, but because of the high salt content, it does sink down to that intermediate level. And as it exits through Gibraltar, Coriolis spins it to the right, deflects it to the right, and basically sets it on a trajectory into the Arctic Ocean. So, you still have this warm water moving in, and it's getting warmer. So still full of that latent heat energy, and it's moving right into the Arctic Ocean, it will still prevent ice formation till later in the year. It will still help melt the ice earlier in the year. That heat will still diffuse to melt the ice. And when there is no ice, that heat will still continue to diffuse into the atmosphere. So, yes, it's correct to be concerned about AMOC Gulf Stream because there are other ramifications, sea level rise, regional temperatures. But as far as impacting the global system, I do not see that, mainly because of all that ocean heat energy that is now persistent and exists. As I said, instead of hemispheric cooling, it's going to be regional cooling. That's my assessment. So you're still going to have the Mediterranean water that becomes the North Atlantic intermediate water, bringing heat to the high latitudes, continuing to warm the high latitudes. That will continue. So what I see is the main problem with the slowdown, potential stoppage of the conveyor belt is what happens to ocean productivity. If you have stratified oceans, which is where we're headed, and there is some stratification going on now, then productivity will eventually come to a halt because the phytoplanktons will use up all available nutrients. And without the mixing to bring in replacement, replenishment of the nutrients, productivity will decrease dramatically, if not come to a stop, which then collapses the food web. And when you consider how many hundreds of millions of people rely on the oceans for the protein source, that is a major concern. So basically, I just wanted to kind of put things in what I consider to be proper perspective, and that yes, we need to be concerned about what's happening with AMOC in the Gulf Stream, but because of all the ocean heat content, I do not see a hemispheric or global cooling down. I see more of a regional cooling down. You're still going to have warm water brought into high latitude. It's still going to be melting the sea ice, and in my view, we're still going to be heading to a blue ocean event. And the Arctic will still continue to warm at least 3 times faster than the rest of the planet. So I hope you found this quick take informative, and I look forward to talking to you again soon.